Okay, so we're just going to do a random selection of rounding problems here, and in each case we're being asked to round to two significant figures. So in our first example here, we're going to cut off after the 5. 7 is greater than 5, so we're going to round this number up to 26. In this case, we have 432,117. We're going to cut off the numbers after the 3. 2 is less than 5, so we're going to just replace those numbers we're cutting off with zeros. Okay, so that becomes 430,000. In this case, we're going to be cutting off after the 3. We have exactly 5 following the 3. 3 is an odd number, so therefore we're going to go up. Up with odd, or over for odd is the way that I remember this, and so that's going to become 0.44. Here we are again. We've got a big number here, 15,510. We're going to cut off after the 5, and this is a little bigger than 5. See, it's 510. So we're going to go up there, and that's going to become 16,000. Okay, so now we kind of put our rounding rules together with our rules for mathematical operations and apply that to the answers of our math. So the first thing you want to be making certain that you've got is a correct calculator answer, and then we can consider our rules for significant figures to decide where to round. So here I'm doing multiplication, so my rounding is all going to be about my sig figs. So I put this math into my calculator and I get a calculator answer, and then I look at what's going on over here. I'm multiplying, so that means it's all about the significant figures. This guy has 3 sig figs, this one has 4, so that means I'm going to round off according to 3 significant figures here. So 15.51766 becomes 15.5. So I'm going to cut this off here. 1 is less than 5, so we just truncate our number. Alright, so now in this second problem here, I'm doing addition. So it's all about the plus and minus. This number here is plus or minus 0.01. This number here is plus or minus 0.1. But this guy in here is plus or minus 1. So when I round the answer off to this sum, I'm going to round off to plus or minus 1. So this is my calculator answer. I'm in trouble if I don't get a good calculator answer, and I'm going to round off to the 1s, so I'm going to round off at the 2 there. 6 is bigger than 5, so I'm going to round this up by 1 to give 373. Okay, in the third example here, I'm doing division, so that means that my rounding is concerned with the number of significant figures. On the top line here, I've got 6 significant figures, but on the bottom line here, I've only got 4 significant figures. So I'm going to put this into my calculator, get my correct calculator answer, and then round off to 4 significant figures. So when I put this into my calculator returns 300. And 300 is in fact written like that without a decimal point or a no overbar, is in fact only 1 significant figure. So how do I make it 4? What I have to do is put a decimal point in. That makes all of my trailing zeros count, and then actually add an extra 0. So now 300 written correctly to 4 significant figures is written as 300.0. In the final example here, I'm doing division and multiplication. So my rule is that I'm going to apply to decide where to round is going to be based on significant figures. The 2 terms on the top line both have 4 significant figures, but the term on the bottom line here has only 3. So when I get my calculator answer, I'm going to round to 3 significant figures. So I put this math into my calculator, and I get a lot more than 3 significant figures, but I know I'm going to cut at the 2 there, and so this is less than 5, so I'm going to leave my number alone, and I'm just going to round off to 3 digits, 3.12. Every now and then we'll get a problem where we have both addition and subtraction occurring alongside multiplication and division. When you do have a problem like this, you should do the addition and subtraction first. You should record your answer to at least one or two more digits than where you should have rounded off. And we don't round off our intermediate calculation, but we take note where we might have rounded, where we would have rounded off if that was the only math we were doing. We then go on and do our multiplication or our division, and then we round according to which of the two parts of our problem has the least number of significant figures. So this is a little bit confusing and you'll need to practice. I'll run through some examples now. So here we've got this problem. There's a multiplication part and there's an addition part. We begin by doing the addition. So I do this addition and I get this as my calculator answer, and I know that this has uncertainty plus or minus 1, this guy has uncertainty plus or minus 0.01, and this guy here has uncertainty plus or minus 0.001. So I know that if this was the only part of the problem that I had to do, I would have rounded off at the 0.1 position. So I just made a note of that by making this bold. What you'll probably do is put a little line underneath where you would have round off. And then I always make certain that I carry through a couple of extra digits. In this case I carry through all of the digits because why not? It's just sitting there stored in my calculator. So step 2 is to do the multiplication. And I'm going to do the multiplication, and so I'm going to take note now, because we're doing multiplication, which of the two parts of my problem has the least number of significant figures. So the sum of those first three numbers there, if I had correctly rounded off, would have had 3 significant figures. Okay, and then the number that I'm multiplying the answer from that sum by actually has 4 significant figures. So what this is telling me is that in my final answer I want to be rounding to 3 significant figures. So I take my calculator answer and I know I'm going to round off after the 0 here. So 7 is bigger than 5, so I don't write 250, I write 251. So the important point here is that I do the sum first. I don't actually round off, but I take note where I would have rounded off if that was the only part of the problem. I then do the second part of the problem, which is the multiplication. I include at least 1 or 2 extra digits from the answer of my first part of my problem when I do this math, and then finally I round off according to the rules for multiplication. So it's definitely a little bit complicated. Here's another one. I've got an addition occurring and I've also got a multiplication. My first step is to do my addition, and I want to be taking note of where I would have rounded that off. So this guy has uncertainty plus or minus 0.01, and this guy has uncertainty plus or minus 0.1. So here's my calculator answer, and I've made note by making the 8 bold that if that was the only part of the problem, I would have rounded off at the 8. That is, I would have rounded off at 2 significant figures. Now I continue on with my unrounded answer to do the multiplication, and I'm taking note of the significant figures of each part, because that's what's important in determining the significant figures in a multiplication. So this guy here has the leading 0 doesn't count. It has a decimal point, 1 non-zero number and 2 trailing zeros. So this guy has 3 significant figures, and then the answer from my first part, if theoretically, if that was the only thing I was doing, I would have rounded that up at 2 significant figures, but you can see I always carry through all of the digits, or at least 1 extra digit, but I know that that number has in reality only 2 significant figures. Therefore, my calculator answer, I know I'm going to round off to 2 significant figures. As 3 is less than 5, I'm not going to increment my last digit, I'm just going to leave that as 2.7. Alright. So something we have to consider when we're doing calculations is the roles of exact numbers. Exact numbers never limit the number of significant figures in our calculation, and how we can make sure that we're always treating exact numbers correctly is to consider them to have infinity significant figures. So a good example of this are unit conversions, and here's a unit conversion here. It says how many inches are there in 3.25 feet. The number of inches in a foot is a unit definition, and so therefore it is an exact number. So when I do this math of 12 inches per foot times 3.25 feet, the 12 doesn't have two significant figures. The 12 is considered as having infinity significant figures. So it is not got two significant figures, it's actually got infinity significant figures because it is an exact number. So that means that the number that has the least number of significant figures is our 3.25, and so therefore our answer is given to 3 significant figures. If we had gone with our initial kind of inclination of saying that 12, well, that's 2 significant figures, we would have got the wrong answer if we wrote 39 without the 0 on the end. Okay, so we've kind of looked at how we round numbers, and we've looked at how that kind of becomes important when we start doing math and applying our significant figures rules for addition and subtraction, and also for multiplication and division. By far the most difficult problems are where we've got more than one kind of operation and we're having to apply both significant figures rules in the one problem. You'll need to practice that. These few examples won't be sufficient for you to have mastered those skills.